Good morning, good afternoon, and good evening. Welcome to the Crazy Hat Chemist. Little reminder here, I am the Crazy Hat Chemist, where you get all the things that you need to learn real, true chemistry, not that junky stuff. So here we go. Today we're going to be doing ionic bonds worksheet number 2. This deals with ionic compounds and elements and polyatomic ions. Okay, so before we get started on this, we need to know a couple of things on our periodic table, of which will be very important. And so we are having our periodic table and we are looking for periodic trends of certain elements. And in group 1, that's a 1+ charge. In group 2, that's a 2+ charge. And then we have this diagonal pattern of 1+, 2+, and a 3+. There are other patterns here on our periodic table, but for the most part, that's what we're going to be dealing with today. Then the other thing that we got is a chart here on charges of oxidation numbers and ions. I'm going to show you that in just a sec. That's right, folks. Here it is. The charges on ions and oxidation numbers is right here. It's a very inclusive chart here. What we just mentioned before, we just mentioned, so let me zoom in on certain sections of this here. At the top right over here, we have 1+, 2+, 3+, 4+, and 5+. These are cationic charges of monoatomic cations. These are coming from metals. Then we have monoatomic anions, nonmetals, 1-, 2-, 3-. We are not going to get into these monoatomic anions today. That will be another day. We have a middle section of transition elements, but we won't be discussing that today. What we will be honing in on is this lower section right over here. Let me see if I can get that here. And that is right here. This section right here, these are called polyatomic ions. And they're grouped together in a -1, -2, and a -3 charge. There is only one ammonium ion, and that is the only cation that is there of the polyatomic ions. Remember, again, I am the Crazy Hat Chemist, so this is where you get all your great chemistry needs met. So let's, without further ado, let's get working on this worksheet. We're going to be using this sheet of paper here to answer some of those questions. So let's zoom on out and see if we can do these problems here. All right. So fantastic. We've got this. This is, again, Ionic Bonds worksheet number 2. Okay, I've already done worksheet number 1. Make sure you watch that. And so that you have everything that you need for ionic bonds. Okay, so here we go. There is an example problem, and that is calcium, and that is a Ca2+. So I have calcium, that's right there. It's a 2+, and that's why I have Ca2+. Okay, then it's nitrate. I'm going to find that in my polyatomic ion section. It happens to be right here, nitrate. That corresponds to NO3 - 1. NO3 - 1. I'm going to get the cationic charge of +2. There's going to be one of those, and the anionic charge of -1. There's going to be two of those. That way, the sum of these two will add up to 0. And then I'm going to take this 2+ charge, circle it, this 1- charge, circle it. I'm going to ignore the positive and ignore the negative. I'm going to take the bull by the horns. I'm going to flip it and bring it down. That is, this 1 comes down here. This 2 comes down here. That is, the index finger is the 2 cationic charge. The pinky is the 1 anionic charge. So I'm going to take the bull, flip, bring it down. Bam, that's the formula. That's why this is a 1 right here, but we don't write 1s, and that's a 2. I'm going to have parentheses around this polyatomic ion because 2 is greater than 1, and that's why we need that. All right, let's see if we can actually do an example and have it written out. The first one is sodium carbonate. Sodium must be a cation. It must be a metal. I need to find sodium. Here it is right here. Sodium, that is going to be an Na1+. You could also use your periodic table and figure out that sodium is a 1+ charge because it's in group 1. Then I am going to have carbonate. Carbonate is a polyatomic ion because this worksheet covers polyatomic ions. polyatomic ion of carbonate is right here in the 2- charge category. It's carbonate. It is CO3 2-. So I'm going to write that down, CO3 2-. So what am I getting from here? There is a 1+ charge on the sodium. There is a 2- charge on the carbonate. I need to add up these two numbers such that they equal 0. And how do I do that? Well, I'm going to multiply this one by 1. I'm going to multiply this by 2. That would give me a sum of 0. The other really short way to do this is to take the bull by the horns, and that is to take the index finger of a 1 plus the pinky finger of a 2-, get rid of or hide out the positive and negative charges, take the 1, the 2, flip the numbers, bring it down. That's why this 2 belongs here, this 1 belongs there, and I'm going to write down my formula of Na2CO3, and then there's a parentheses and a 1. But because I don't write ones, because I don't write ones, I don't write the parentheses. So just a real quick on this, why do you not write ones? Well, have you ever been in a math class? I sure hope so. When you have the variable x, there's actually a 1 coefficient in front of it and a power of a 1. But do you write the 1 coefficient and the power of a 1 when you write the variable x? Heck no. So you just write x. That's why you don't write ones. Just to clarify, if I have the variable x and there's a coefficient of a 3 and a power of a 2, what do you write down? Well, you write down the whole thing, the coefficient of a 3, the variable x, and the power of a 2. But when it's a 1 coefficient or a 1 power, you don't write it. And that's why you don't write those ones. So I'm going to take my pencil and erase those right there like that. Okay, perfect. Let's do the next one. The next one is potassium and then hydroxide. Potassium is right here. That's right here. And that's a K with a 1+. So I'm going to write a K with a 1+. And then I'm going to find hydroxide. Of course, that is a polyatomic ion because that's what we are talking about here today. That's hydroxide, and that's an OH1-. So that's an OH and a 1-. Okay, this whole entire column here is equals to 0. So you can actually fill this entire column out and say it equals 0. Why? Because ionic compounds must equal 0. That's a +1 charge, a -1 charge. I need to find a way to add up these two numbers such that they equal 0. So I'm going to multiply both of them by 1. Okay, and how do I do that here? I'm going to take this number, circle it, take this number, circle it. This is the cation. I'm going to ignore the positive charge. It's the anion. I'm going to ignore the negative charge. I'm going to take the bull by the horn, flip, bring it down. And what do I get? I get K. I'm going to write this in pencil now. 1 OH parentheses, because it's a polyatomic ion, and a 1. Question, do I write ones? No. Okay, get rid of the ones. Do I write parentheses if the 1 disappears? Heck no. That's right. So the formula is KOH. Bing! Let's do the next one. That's a barium phosphite. And so barium is right here in the 2 category. There's barium, and that's a Ba2+. Ba2+, phosphite, that is in the 3- category. It's phosphite. Make sure it's not phosphate. That's very close. So phosphite is PO3 3-. PO3 3-. We're doing the same thing that we've been doing all along, and we're going to take these two numbers and then add them up. And they must equal 0. So I'm going to multiply this by 2 and this by 3. Hopefully you see that. Okay. The other way of doing it is circling this cation, circling that anion. I'm going to scratch out the positive and the negative, take the bull by the horn, flip, bring it down, and I'm going to get Ba and then this PO3. Okay. The Ba with a 3, then it's PO3 parentheses and a 2. Why do I have the parentheses? Because I have a polyatomic ion and there's more than one. That's why. That's right, folks. All right, let's keep on going. The next one here is barium nitrate. I'm not letting you sleep, am I? That's good. Okay. Barium 2 plus, Ba 2 plus. We just did barium for goodness sake. Okay, and then nitrate. Don't stay up too late because the nitrates are better than the day rates. Nitrate, that is NO3 minus 1. Now, hopefully you caught that joke. That's NO3 minus 1. This is a 2 plus. This is a 1 minus. I'm going to somehow add up these two numbers such that they equal 0. I'm going to multiply that by 1, multiply that by 2. That's the same thing as taking the bull by the horns, crossing out the cationic gas, crossing out the anionic, taking the bull by the horns, bringing it down. I get Ba and the NO3. And then I'm going to put parentheses around that NO3 and a 2. Why is the parentheses there? Because this 2 is greater than 1. Next one is aluminum hydroxide. I'm going to find aluminum here. That is, aluminum is right here. It is Al with a 3 plus. Al and a 3 plus, and then hydroxide. No way, I think we've done it before, but there is hydroxide. That is an OH1 minus. So that's an OH and a 1 minus. It's a 3 plus charge and a 1 minus charge. I need to find a way to add up these two numbers. I'm going to multiply that by 1, that by 3. They will equal 0. Another way of looking at it is circling that number, ignoring the positive, ignoring the negative, flipping the numbers and dropping them down. So I'm going to have Al and the OH. And then there is an imaginary 1 right here, and then there's a parentheses with a 3. Oh yeah, you do need the parentheses because that's 2 capital letters, that's a polyatomic ion, and that 3 tells you you have more than 1. All right, we have done halfway through this worksheet here. Now we're going to focus on the reverse of these types of problems, which is taking the formula and going backwards. Now, the net charge must equal 0 on all of these, just like before. So nothing has changed there. All right, so this first one here, I have 2 polyatomic ions. I'm going to put a parentheses around this, put a parentheses around this. I'm going to put a 1 and a 1. I'm going to flip those numbers, and I'm going to pull them up. So I'm doing the opposite of the bull by the horn, flip and bringing it down. I'm going to take the bull by the horns, flip and bring it up. Yep, that's right. All right, so this first formula here is NH4. The second one is NO3. The cation always comes first. The anion always comes second. So I need to find where these two are, okay, on my sheet of paper. Look at this. That is this NH4. It's a 1 plus. It's the ammonium ion. There's only one polyatomic cation. And we've already done this NO3. We've already done this NO3. It's a 1 minus. So you should be familiar with that. That's a 1 plus, a 1 minus, and lo and behold, if I multiply both of these by 1, then that's why those are 1s right there. The name of NH4, it is the only polyatomic cation. That's a cation with a positive charge. That's ammonium. Ammonium. And then NO3 minus 1, what's the name of that? Nitrate. Perfect. The next one is K2CO3. Every polyatomic ion has parentheses. I'm going to put a 1 there. I'm going to take this 2 and that 1. I'm going to flip the numbers and bring them up. That will give me a K that's positive of a 1 plus, and then a CO3 that has a 2 minus charge. So a 2 minus charge, a 1 plus charge. Hopefully you're getting the hang of this right here. We're going to add them up and multiply that by 1, multiply that by 2. That's why there's 2 of those Ks. I need to find out the name of K. It's in the 1 plus category, so I don't have very far to look. It's in the 1 plus category. It's a K1 plus. That's potassium. All right, now I need to find this next thing. This next thing is CO3 with a -2, okay? So this -2 lets me know what category I'm looking in. So I'm going to look at the -2 category. I'm going to find CO3 -2, and the name is carbonate. So I'm going to write that down, carbonate. You do not change the name of these polyatomic ions. All right, here we go. Next one. I'm going to put a parenthesis around the polyatomic ion and a 1. That 1 comes up. This 3 comes up. Oh, yeah, that is beautiful. So I got an Na with a 1 plus. I got an ASO4 and a 3 minus. -3 and a +1, you should see that what has been done is that there are 3 of these NAs and 1 of these ASO4s. I'm going to look on the 1 plus category and the 3 minus category to find the Na that's a 1 plus. What is the Na that's a 1 plus? Well, that's sodium. Sodium. And then ASO4 in the 3 minus category. In the 3 minus category, ASO4, 3 minus, that is arsenate. It's that simple, folks. All right, here we go. Next one, NH4, and there's a parentheses and a 2, and then there's a CO3 parentheses and a 1. I'm going to take that 1, flip, bring it up. This 2, flip, bring it up. Okay, that lets me know I'm going to have an NH4 with a 1 plus and a CO3 with a 2 minus. That's a 2 minus, that's a 1 plus. And you should see that for these here, there's 2 of these, 1 of these, I've added them up, they equal 0. Okay, I am going to look in the 1 plus category and the 2 minus category to find the names of these. This is a polyatomic ion, so there's only one, and that's ammonium. Ammonium. And then CO3 is in the 2 minus category, 2 minus category. CO3, that's carbonate. We've done that before. Okay, now for the most difficult one. There's a number right here, and there's a parentheses around every polyatomic ion. There's a number right here. I'm going to flip, bring it up, flip, bring it up. Okay, and I get Mg and then SO4. I know this is negative. I know this is positive. Now, this one is a little bit tricky. So Mg, where is Mg? I'm thinking that it's in the 1 plus, but sadly, I do not find it in the 1 plus category whatsoever. So I'm going to look in the 2 plus. Oh my gosh, there it is, Mg, and it is a 2 plus. It's magnesium. Magnesium. It is a 2 plus. So now, when I brought these numbers up, I got ones. 1 to 1 is the correct ratio, but magnesium is actually a 2 plus. In order to maintain that 1 to 1 ratio, this SO4 must be a 2 minus. So this is a 2 minus. So now I'm going to look for the 2 minus category of SO4. In the 2 minus category, I find SO4, and it is 2 minus, and the name of that is sulfate. Perfect. Of course, that is a 2 plus and a 2 minus, and we are adding them up, and there's one of each of those. That's why I get that. All right, we have 2 questions to answer here at the very bottom, and that is, what is a polyatomic ion? And that is, it's an ion composed of 2 or more covalently bonded atoms. Okay, that's actually on my sheet of paper right here. Actually, it says polyatomic ions, an ion composed of 2 or more covalently bonded atoms. So it's actually on my sheet of paper if you care. And when are parentheses required around polyatomic ions? When the number is greater than 1 and not reduced. And hopefully you can see that in examples on this worksheet. Let me zoom on out. So we got the entirety of this worksheet here. Let's keep on going. So we got this whole thing on here. Oh yeah, baby, there we go. There's everything right there for you. I hopefully you got that. I'm hoping that you're learning something, and that would be a good day. So I hope you have a fantastic day. I'm going to see you next time. Please like and subscribe. I love you. Have a great day. Bye for now.